Hi, and welcome to Active Directory in the AWS Cloud. My name is Wayne Sachs. I'm a solutions architect with AWS. I work with our systems integrator partners. Thanks for coming. I hope that this is enjoyable and useful for you all. Just to kick things off, who here owns, operates, or manages an Active Directory infrastructure in their own environment? There's a lot of hands. All right, who's deployed in AWS? And who has extended their data center into AWS with AD? All right, so there's a good amount of experience here, and I hope that we can shed some light on some options, scenarios, best practices. So our agenda today is going to look at several deployment scenarios, to start with a hybrid data center. Then we'll move to federation, and then an isolated deployment. Once we've talked through some usage patterns, we'll work through some general design considerations, things that I think are really important for deploying a healthy Active Directory in AWS. Finally, we'll shoot through a couple additional resources and further information for your own self-study and guidance. And then Q&A will, I think, be in the hallway after the session. So our deployment scenarios are all going to be based on the core pieces of AWS. Network with VPC, security groups, direct connect, VPN, compute, leveraging EC2 and storage with EBS, and deployment and management with CloudFormation, CloudWatch, and identity and access management. And there will be more that we won't necessarily call out specifically, but I think the larger takeaway is that you need to be fairly comfortable and confident with the breadth and scope of AWS services in order to get the best usage of your Active Directory. The hybrid data center is a very common scenario that we see in AWS and Active Directory. And it takes advantage of either a VPN or a direct connect link. And you'll be designing your VPC to be an extension of your data center, right, in this scenario. The advantage of this is that you take advantage of, that it minimizes administrative process change. We'll look at a scenario where you might be migrating a portion of your on-premise data center to AWS, including a Windows service or services that rely upon Active Directory. There'll be two design patterns that we dig into: an on-premise Active Directory only, and a deployment of domain controllers in AWS. So the scenario here that we see is an AD in your on-premise only. And what you're looking at is a Kerberos path for authentication. So in this scenario, user on-premise needs to gain access to services that are hosted in AWS. A VPC is used to host the AWS infrastructure using a compatible IP address space that's complementary to the on-premise environment. In this scenario, the AWS cloud is treated very similarly to a branch office that doesn't have a domain controller. The advantage of this model is the ease of deployment. It takes advantage of the cornerstones of Kerberos Authentication, allowing you to rely upon your trusted network, which means that the VPN or the direct connect that you see in the middle there must be well secured. The challenge with this method is that all AD services, not just authentication, of course, will traverse that link, which will introduce latency into the process, particularly for LDAP-heavy applications. So if you tried to do this with an Exchange infrastructure, for example, that had a lot of users, you'd probably find your user experience to be pretty poor. So due to the inherent limitations of this scenario, it's probably best suited for a test dev environment and not necessarily for production. Some major design considerations that you'll take into mind when you're deploying a scenario like this will be that you'll be using DHCP option sets, most likely, to ensure that new servers that spin up in your VPC are assigned the appropriate DNS and NTP settings. And NTP is particularly important in order to maintain time synchronization for Kerberos authentication. As soon as that drifts, you'll see authentication breakdowns and Active Directory misbehaving. You'll need to make sure that there are redundant routes that are available between the AWS cloud and your on-premise environment. Without those multiple routes, you'll find yourself in a scenario where you might orphan your AWS cloud. And you'll need to ensure that network traffic is routable both directions, which is configuration for the networking folks who are in this room. Scenario 2 looks very similar to scenario 1, where you're taking an Active Directory domain controller and moving it over to the AWS cloud and out of your remote office. The diagram you see here is probably what you would do if you had a remote office that you don't necessarily trust to maintain a domain controller. Most remote offices don't have cage-locked facilities. They wouldn't necessarily have the proper heating and cooling. You may not have personnel who you can have support a full writable DC. In this scenario, you deploy a domain controller from your on-premise forest, and it could be a new domain, or it could be an extension of your existing domain. Again, a VPC is used to host the AWS infrastructure, and we still need to use the compatible IP address space. The advantage of this model is that the deployment is very simple. You pretty much just spin up an instance and run DC promo on it. But in this case, ADDS services are hosted in the AWS cloud, which is probably more secure for a lot of reasons, hopefully most of which you've learned about this week, than a remote branch office. The disadvantage of this scenario is that your users in the remote office won't have access to their domain controller should the link go down. So again, it's vitally important here that either you have a way to give them an alternate route to a domain controller, more than one connection between the VPC and the remote office, or you're giving them something like cached credentials on their local machine, so at least should the link go down, they're not out of business for an afternoon. We'll use the same general design concepts, including DHCP option sets, authentication traffic routing, et cetera, that we did in the first hybrid data center scenario. The other option on this is, and I don't have a good picture for it, is you could also place that domain controller locally in the remote office. And that way you'd have two DCs, one remote, maybe a read-only domain controller, and one in the AWS cloud. That would isolate authentication traffic and allow you to maintain some levels of synchronization without having necessarily the heaviness of full writable domain controllers. AD Federation builds on the basic model that we just talked about in the hybrid solution. But this time it provides single sign-on capabilities without extending your corporate Active Directory forest. This is the cornerstone of empowering B2B, business-to-business trust. When an application is in one network and users are in another network, it's typical for users to encounter prompts in order to gain access to applications using some sort of secondary credential. These secondary credentials represent the identity of the user in the realm where the application resides. Users don't like this very much. Domain administrators don't like this very much. It increases a lot of overhead time, and help desks tend to get overloaded with calls for password resets. So it's not necessarily very easy to deal with. So ADFS makes secondary accounts and their credentials unnecessary by providing trust relationships that you can use to project a user's digital identity and access rights to trusted partners. In a federated environment, each organization continues to maintain its own identity, but each organization can securely manage and accept identities from other partner organizations. Furthermore, you can deploy federation services in multiple organizations to facilitate business-to-business transactions between trusted partners. So in this example, a user in an on-premise Windows domain wishes to gain access to Windows applications that are running in Amazon EC2. We leverage the Windows Identity Framework here, which has been installed on the EC2 instance in which the application is running. While it's not absolutely required, the WIF greatly reduces programmatic overhead for federated authentication. The WIF allows both browser and non-browser client applications to take advantage of the ADFS. This application, the hypothetical application that we've got here, is configured to trust only the identity information supplied by the ADFS server that's in the on-premise Windows domain. The WIF provides a general interface for working with claims in a token and allows the use of an identity selector such as Windows card space. So your users would have the ability to choose an identity as they're logging into an application. The clients here start by logging into an Active Directory domain. Now, this would be the normal morning activity. Sometime later in the day, they're going to try to get into this application that's hosted in the AWS cloud. So they're going to query the application for their token requirements. And they're going to return, in return, get those requirements. The token request is going to be sent to the ADFS server in the form of a Kerberos ticket. With a Kerberos ticket. ADFS is going to look to Active Directory Domain Services, ADDS, to find and return that claim. ADFS is going to hand the token back to the user, and then the user will, in turn, hand over the token to the application. Here, the WIF is going to resolve that token, and it's going to evaluate the claim based on canonicalization, based on uniqueness, timestamp, et cetera. And if it decides that this is, in fact, a valid claim, the application is going to return the data or the access to the application as it's been requested. This example is a really good option if the organization that owns the Active Directory infrastructure also owns the applications that are running in the AWS cloud. This is not a good option if these two organizations are not one and the same, because you'd never want to build into your own application infrastructure inherent trust to some untrusted or unmanaged authorization domain. Which brings us to the SaaS model of federation. So the SaaS model of federation is very useful if the application for which you want to provide access is in an unmanaged or untrusted domain. In this, you're establishing a trust between a source domain and the AWS domain via ADFS for trusted login. So I'll let you take in this model for 1 second. So the previous example was configured to trust ADFS server in an on-premise domain. So that's good, for example, for situations where a single organization owns all of the infrastructure and shows an example of being able to provide access to users who aren't necessarily on the corporate intranet at all times. But if the application is a SaaS-type application, accessed by users in different organizations, the previous example does not work. You wouldn't want to configure your application to implicitly trust another domain that you don't own or manage. So instead, a better approach is to create a new Windows forest in your AWS VPC and install ADFS there. Once you have built the ADFS infrastructure in AWS, it can be configured to trust the local ADFS server rather than one that's in the on-premise source domain. AWS-hosted ADFS can then be configured to trust ADFS servers in the on-premise domain that contains the users of the cloud-based service that you're trying to offer to the market. So this is the real power of ADFS. What this example doesn't necessarily show you is how to secure ADFS in the cloud environment, which is really critical, and that we'll talk a little bit about a few slides down. But the most important takeaway is that you should never place core ADFS servers in a DMZ. There's proxy elements that you would use to put in front, right? Because if you don't, you've opened your environment to anybody who wants to get in. Different versions of Windows Active Directory, versions 2003, 2008, and 2012, provide slightly different ADFS style mechanisms, but the core ideas and the design choices look very similar. One of the big differences will be ADFS 2.0 versus 1.1, and its ability to manage application, 2.0's ability to manage application authentication as well as web, and 1.1 really managing web only. So you'll need to pick the appropriate ADFS infrastructure for the applications and services that you're trying to present. The last scenario that we'll look at is an isolated one force in the cloud scenario. So this does not require any sort of connectivity between your on-premise data center and AWS. It's good for applications that manage their own internal users, And it's good for applications that require Active Directory, but you don't necessarily want to host any corporate information in the cloud. It's not a terribly uncommon design choice, and probably one of the fastest ways to get up and running with AD in the cloud. So this slide shows a visual representation of the Active Directory architecture example that's hosted in our architecture site. There is a full detailed set of documentation about this example, including the CloudFormation templates that are used to build the VPC, the sites, the subnets, the Active Directory domain controllers, and the security groups. The important elements that you see in this are the fact that you've got a DMZ with NAT and jump boxes, some sort of isolation between your applications and your databases, and the domain controllers as well that are isolated. You want to maintain authentication and network flow control between the various levels of this infrastructure. And you could actually apply this infrastructure pretty well to all the other authentication paths that we just looked through. And this is, in fact, I think, one of the strongest starting points for any deployment in AWS, regardless of Microsoft or Active Directory at large. Some general design considerations that you'll always want to apply when you're building Active Directory in AWS are going to start with the first maybe thing that's been pounded over and over at this conference, which is avoiding single points of failure. I think we have a saying here generally that everything breaks all the time. And when you have an Active Directory infrastructure that's hosting critical authentication or application information, you need to put yourself in a position where ADDS services or Federation services are available to those who need them all of the time. This is not one of the applications that can be turned off on weekends very often. So to that point, and to that end, it doesn't imply that you need to have two domain controllers always running in AWS, but it does mean that you need to have two domain controllers that are available to clients that are in AWS, or clients that are in your on-premise domain reaching into AWS. That means you need to ensure that your route tables are configured properly. It means that you need to ensure that DCs can communicate with each other and that replication isn't broken. Otherwise, objects will linger or get stale. You won't have consistency between the databases. You want to treat AWS availability zones as you would distinct data centers. And we'll talk a little bit more deeply about this in a minute. But the concept is that you would typically not have a data center without a domain controller. And you'll probably not want to have an availability zone without one as well. Finally, you need to consider really carefully the characteristics of the shared computing environment. In particular, when you're sizing an EC2 instance to host an Active Directory domain controller, you need to think and start probably with the size of the RAM. So Microsoft's recommendation for RAM for a domain controller is that it's large enough to hold the entirety of the database, sysvol, the operating system minimum requirements, and any requirements for additional agents that you'd install, like antivirus. So that actually could be a pretty large amount of RAM. If you don't want to have an instance that is that large, then you need to think about the amount of times the Active Directory is going to have to query into the hard drive to pull that information, and the implications for authentication or authorization to your application. So again, going back to the example of an Exchange infrastructure, you might find yourself in a bad position if your Exchange infrastructure is hosting a lot of users and constantly querying into Active Directory with a domain controller running on a T2 small. The other thing that you really need to think about, and this is actually quite advantageous of the AWS style infrastructure, is that you want to scale out instead of scale up. So AD likes to scale out also because domain controllers are easy to promote and can share load across each other. So instead of building one or two very small Active Directory domain controllers, we recommend that you scale out to multiples. It also gives you the advantage of having multiple failure points so that you can survive failure a lot more fluidly. You need to understand your VPC and networking backbone because it's going to play a very, very large role in the design of the Active Directory itself. If you're going to connect to an on-premise data center, you have to understand the implications of your connectivity choices to your topology, particularly if you're doing heavy types of replication, or if you have a lot of stuff in your sysvol, if you're installing applications with Active Directory, right? You have to be sure to monitor your replication, the load between the inter-site replication and the load between the intra-site replication, to be sure that you're not saturating whatever available bandwidth you have between those various sites. Something that we see pretty often, because we in the Active Directory and system space don't always think about VPN and traffic, is that when you have a VPN stood up, it'll typically close off if it doesn't have what's called interesting traffic against it. That manifests itself in replication just all of a sudden stopping typically every 1 minute, which is quite frustrating. So all you need to do in order to keep that up is send a ping once a minute from your side to mine. It's a very easy thing to do, but it's extremely easy to overlook as well. You also need to make sure that you're using static IP addresses. So remember, when an EC2 instance spins up, DHCP assigns it an IP address. And it's not a common practice for us in the physical environment to go back into the operating system necessarily and assign a static IP address via the OS. But you absolutely need to do it. The reference architecture that I pointed out earlier has a very elegant way to do that as part of the user data with a PowerShell that is like 2 lines long. Super easy to do, but very effective, and one that you must do. And lastly, security groups and firewalls add complexity to your replication topology. AD relies on RPC for replication. And getting that can be a challenge when there are security groups that filter traffic that sit between your Active Directory domain controllers, particularly because RPC likes to use ephemeral ports. So there are a variety of options, and each one has its own trade-off. And I like to think of them from low to high. So option number 1 is you can open the security groups between domain controllers to allow unlimited traffic between DCs, but only DCs. Option 2 is you can limit the RPC's use of TCP to only ports and protocols that you define. And then you can open your security groups to just those. So that's like kind of a middle way. And then finally, you can encapsulate DC to DC traffic with IPsec, and then only open security groups to IPsec traffic. That's the most secure. Also, easily the most complicated. So this is a trade-off that you'll need to make with the various stakeholders and probably the folks who are responsible for your security to determine what it is that you want to get out of the domain controller security group policy and what your requirements are, if there's any regulatory requirements or business level requirements. Backing up and recovery of Active Directory is critical. One of the first environments that I worked in thought that you didn't need to back up Active Directory because it replicated, right? And they were like, we don't have to do that. It replicates. But of course, a bad object replicates, and then you are out of business very fast. Microsoft best practice is to use an AD-compatible backup application. And it's not just Microsoft best practice, but it's absolutely critical for the health of your environment. So a number exist, such as Windows Server Backup, and a whole bunch that are currently on the marketplace today. Since a lot of you raised your hands saying that you have an Active Directory infrastructure on-premise, and many raised hands saying that you have something in AWS, there's a very good chance that you're backing up your AD today using a commercial off-the-shelf type of a product. Thankfully, most of those products are a part of the AWS marketplace, and you should continue to use those, but you must continue to use them. To safely restore a domain controller, all of the AD data, all of the log files, the registry of the domain controller itself, and sysvol, and some OS elements must be captured. So it's not sufficient just to dump a piece and hope that you've got enough. You will not be able to restore a domain controller in that scenario. The other thing is, during a restore process, replication partners of those domain controllers must be notified of the invocation ID to protect against USN rollbacks, and we'll talk about that in 1 second. The system state must have been created by an AD-aware backup service and within the timeline of the tombstone setting, which is 180 days. Otherwise, the backup will be rejected. So if you haven't changed the tombstone, then you must be backing up your AD every 6 months. The next point is that you need to know the unique requirements that are driven by the virtual environment. And this has to do with both backup and recovery as well as deployment via snapshot. And the answer is you can't do either one of those things via snapshot. So if you deploy a snapshot of a domain controller, either as part of your provisioning process or as part of your backup process, you will bypass the critical step of updating the database version. Every DC maintains a table per naming context, which is the partition of the domain. It's called an up-to-dateness vector. These tables record the data from when objects were replicated last or when attributes were replicated last. And as things are replicated, domain controllers compare the replication values of the up-to-dateness vectors to determine who has the most up-to-date object and to accept an object or to reject an object. If you take a snapshot of a directory, of a database, and you apply it to your infrastructure, the up-to-dateness vector will become out of sync. So a domain controller that has not been recovered from snapshot will think that some date is the most recent date, and another domain controller will think opposite. It's called a USN conflict, and it can cause dramatically bad things to happen to your domain. If you're lucky, and usually you will be, replication will just grind to a halt as the directory seeks to protect itself. If you're not lucky, and it's happened to me, then you'll be sleeping under your desk for a week because stale objects will replicate, passwords will roll back. If you did a schema upgrade, that will go away. So these are very bad things that you want to protect against. So it's a long way of saying don't snapshot your domain or a domain controller and expect to restore from backup. Just as domain controller physical security should be very important to you in your on-premise environment, your EC2 domain controller security should be very important to you in your AWS environment. You probably don't have a domain controller sitting under your desk. It's probably in a locked cage in a locked data center. And so you need to do the same thing to your domain controllers in EC2, which most likely means that you're controlling IAM access via two-factor authentication. It also means that you need to control who can provision, who can restore a backup, and who can turn on a domain controller, just physically powered on or physically powered off. A very powerful and elegant way to accomplish that goal is to require that only domain controllers be deployed via CloudFormation, which can manage and maintain the entirety of the domain controller spin-up process and can be locked away to only those who should have it. Domain controllers themselves, like I mentioned, should not be internet-facing. So for ADFS, you should be using web application proxy services for the front end in the DMZ. And lastly, AD best practices still do apply, which means that you need to maintain who your enterprise admins are, your schema admins, your domain admins, and who can turn on and off services, who can present them to other applications. Nothing changes in that respect from the application on up. This is probably the most important of all of the concepts that we'll think about and that you'll think about as you go about deploying and configuring Active Directory in AWS. So your AD design is going to be driven entirely by the layout of the AWS infrastructure that it sits upon. But luckily, the two of them are quite complementary to each other. So we'll start with AD sites. Site design, the AD site design itself is very critical. It dictates both how AD will replicate internally to a site, as well as how clients will reach and communicate with domain controllers. So it's very important to think this part through carefully. On the replication component of the site topology, site topology itself is represented by the physical network, the LANs and the WANs that connect domain controllers in the forest. The replication topology is built to use the site topology. The replication, the AD site topology is generated by the Active Directory Knowledge Consistency Checker, the KCC. The KCC builds connection objects between domain controllers and between sites. These objects influence Active Directory replication so that AD replication achieves the best balance between the speed of replication and heaviness of replication, the cost of replication across a WAN link. When the KCC generates replication connections, it creates more connections between DCs that are in a site than DCs that are across sites. So the results are lower replication latency inside of a site and less bandwidth used across sites. So to further explore the concept, you have to understand how AD clients locate the domain controller. Domain controllers register an SRV resource record in DNS. So when a client wants to get access to a domain controller, it looks to DNS to get the SRV to point it to its closest domain controller. A good, the SRV record that's returned should be the closest domain controller, the one with the least cost to access. So in this way, the client locates its best in-site domain controller. Sites are also used by AD-aware applications like SCCM to locate and to point clients to appropriate resources in the SCCM environment. If a client can't get to a domain controller in its local site, it should try to find one in its next nearest site. That mapping is done by what's called the ISTG, the Inter-Site Topology Generator. If you're running Windows Server 2000 or later, and you should all be at this point, you can specify an alternate site so that the nearest site, should your site fail, the nearest site will become available. In the Active Directory world, a site is defined by a set of subnets that are well connected. It should be LAN speed or better. So the way that a site is defined in AD is essentially the same as the way that we, AWS, define an availability zone, which is a set of well-connected resources. So when we go about designing our sites, we should think of a site to AZ mapping. That's further enhanced by the way that the VPC distributes traffic across AZs. What you should probably not do, on the other hand, is span a site across multiple availability zones, because then you won't be able to control where your local client is looking. It's a higher cost move to authenticate or to gain access to a domain controller across an availability zone. So probably a best practice would be to have one domain controller in one AZ and a second domain controller in the second AZ, and not to get both the benefit of the redundancy and then VPC traffic routing for the event of a failure. The resiliency of your infrastructure is going to depend on the way that your replication topology is laid out. This becomes even more clear if you're spanning multiple regions and potentially including your data center on-premise as well. So in those cases, the cost of replication can actually be pretty high, especially if you're trying to replicate a lot of data from US West 1 to Sydney, Australia. That's a pretty heavy action. It's an expensive action, both from a technical perspective as well as from a cost dollars and cents perspective. So the first thing that you want to remember is that replication is based on site. And then you want to make sure that you're controlling the amount of replication, the speed of replication, the things that you replicate between sites, particularly, like I said, when you're spanning multiple environments. So as I mentioned before, the knowledge consistency checker, the KCC, creates the site to subnet mapping. The KCC reads and writes into its own local database configuration objects that represent both local site replication and intra-site replication. The KCC builds these objects and are presented as part of the replication topology. You can go in and you can edit those to make different cost allocations on your own. But if you do that, the KCC will never go back and update those site records. It's not necessarily a bad practice to manually edit the site connection objects, but if you do that and you find yourself in a failure state, part of a resiliency plan will have to be to go back in and manually edit the site connection objects and the site links. That breaks, in a more fundamental way, the automated efforts that you should probably be trying to do in the AWS environment. The other thing to keep in mind is that when things start to become unwound, they don't look right. When you create an object in one domain controller and you find it not on another domain controller in the appropriate amount of time, it's probably that you've got a replication breakdown somewhere. And that's probably because you have a security group or an ACL that sits in the way. So I found myself troubleshooting deep into the weeds because I just had the wrong setting on my security group. So as a point of reminder and maybe a friendly bit of advice, when replication starts breaking, check your security groups as the first place to go. The last thing I want to discuss, and it's pretty quick on this one, is that there's a role for RODCs in this universe, but I don't think there necessarily is one too often in the AWS world. So the RODC was designed and developed by Microsoft for a branch office, for a place that you didn't have a secure facility to hold a domain controller, and for a place in which you didn't have personnel who could manage that DC. In the AWS world, your domain admin should always have access to your writable domain controllers because they're hosted in the cloud. So it takes away one of the major reasons for having a RODC. The other thing that you want to think about with RODCs is what data is actually stored in the database of an RODC. Well, it contains all of your data except for credentials and credential-like attributes. So if you're using a domain controller for authentication in the ways that we were discussing, and it happens to be an RODC, your users or your applications will never actually talk to the RODC. They will always traverse the link and go find a writable domain controller somewhere else. There would have been no reason to use an RODC there at all. Now, you can, by choice, forward cache credentials in RODC, but then if you've done that, why do you have an RODC to begin with? So I guess my takeaway on that is it's probably not worth using RODCs in an AWS world. So there's some additional resources that I just want to point out very quickly. There's a set of Microsoft reference architectures, including Active Directory, SharePoint, remote desktop gateways, and the PowerShell DSC. These are great uses, the great use cases, CloudFormation templates that will help you deploy and deliver AD very quickly, and the like services, as well as building out the VPC with the security subnet groups that I showed in the first set of slides. We have a set of Microsoft pages in AWS. The white paper called Securing Windows-Based Applications on AWS is very important, and you should probably all read it if you haven't yet. As well as the Windows detail page in the Microsoft Licensed Mobility Program. So for anybody who wonders how they can get SharePoint or SQL Server into AWS, that's where you want to go. And then finally, from the Active Directory side, the tools that I find very useful, I hand out links pretty regularly, are the capacity planning for ADDS, directory replication over firewalls, Active Directory replication concepts, federation services, and troubleshooting AD replication. So I think these links will be available in the slides whenever it is that they're posted. So with that, I want to thank you for coming. I hope that this has been valuable concepts for Active Directory in the AWS cloud. If you hit the link, I think that takes you to a feedback mechanism. So thank you very much. I think we'll probably take questions and answers in the hallway after everybody has gone. So thank you.